Okay, so let's talk about covariance. Now, the definition of covariance is it's really the mean value of the products of the deviations of two variables from their respective means. So this is our definition here. So what we're doing here is taking each x value, for example, and finding its deviation from its respective mean x bar, taking each y value and finding its deviation from its mean y bar, adding them up, multiplying them first, adding them up, and dividing by n minus 1. This is really the sample covariance. It's the sample covariance. We're dividing by n minus 1 here, as opposed to n, because we're looking at a sample here. We're looking at the unbiased version. So this is our definition of covariance. Now, I've written this three different ways here. This is our basic definition, this is another version of this, and this is another version as well. So what I'm going to do in this video is just start with this here and just show you that from this you can derive this formula here, and from this you can derive this formula here. So if you see any of these three versions in different textbooks, you'll know they're all really just the same things. So let's start with this one here. So we're going to start with this definition here, and we're going to try and derive this middle formula here. So let's start with the numerator first. So we're going to start with the sum of x minus x bar, y minus y bar. So we're just going to have a look at this first and rearrange it. So what I'm going to do first of all is just multiply out the brackets here. So if we multiply out the brackets here, we get x times y, which is xy. We get minus xy bar. We'll get minus x bar y, and then finally plus x bar y bar. Now from that then we can just, to find the sum of all these sums here, if you like, it's just the sum of the individual terms. So I can do this here. I can just take away the brackets here and get the sum of xy minus the sum of xy bar minus the sum of x bar y plus the sum of x bar y bar. Okay, so from here now I'm just going to have a look at these individual terms, but before I do that, let me just show you this little note here. You know that the mean of a random variable, so let's say or bar, the mean of some random variable or, is just going to be the sum of all the ors divided by n. So you add up all the ors, divide by the number of ors, that gives you the mean of or. So if we multiply across here by or, we get, or by n I should say, you get n times or bar is equal to the sum of or. So wherever we see here the sum of some random variable, we can just replace it by n times the mean of that random variable here. So this is what I'm going to do now with this line here. So let's have a look at this. We have the sum of xy. Well, that's just going to be simply n times xy bar, based on this here. If we look at this here, this second term, y bar is just simply a constant. The mean of the y's is just a number, it's just a constant. So really we just have minus the sum of x times this constant here. So what we can do with that is just take the constant outside here like this, and then what we can do next, well, we can, well, I'll do two steps in one. I'll just write it down as n times x bar. So the sum of the x here is the n times x bar, and this y bar here, which is the constant, I'm just writing down here. Here again, the x bar is a constant. The mean of the x's is a constant. So here I'm just going to end up with minus, I've got n times y bar x bar. I'll put the x bar first. We'll keep it in alphabetical order here if you like. And at the end here then we've just got x bar and y bar. Well, both of those are constants. So if you have the sum of a constant, it's just going to be n times those constants. Because remember, the sum here goes from 1 to n. Our sum here is going from, if you like, I is equal to 1 up to some value n here. So there are n of these constants, so the sum of all of these is just going to be n times the constant. Okay, so I mean, let me just explain that a little bit better. If you have the sum from 1 to n of, let's say, the number, some constant 4, really what you've got here is you've got I going from 1 to n, but there's no I here, if you like, but you could say that there's an I here to the power of 0. So really what you've got here is 4 times 1 to the power of 0 plus 4 times 2 to the power of 0 plus 4 times 3 to the power of 0, all the way up to 4 times n to the power of 0. Now if you look at this, all these individual numbers here to the power of 0 are just 1. So that's 4 times 1, 4 times 1, 4 times 1, 4 times 1. So how many? So you just end up with 4 plus 4 plus 4, all the way up to plus 4 at the very end as well. So you actually have n number of these 4s. So it's 1, 4, 2, 4, 3 4s, 4 4s, all the way up to n 4s, or 4 n's if you like. So that's where this n times this constant comes from here. Okay, so let me just get rid of that first. Okay, now let me just continue on here with this derivation. So we have down as far as here, so let's have a look at the next line then. Well, here you've got a minus n x bar y bar. Here we've got a plus n x bar y bar. So these two are just going to give us 0. So we just simply end up with n x y bar minus y bar. Well, actually, let me just rearrange that as well. We put the n first. N times, we put the x bar and the y bar in that order. Okay, so what we can do next is just simply factorize out the n. So we've got xy bar minus x bar y bar. Okay, so that's our numerator just rearranged. So remember, we started here, multiplied these out, and we ended up with this here. So look, this here is just the numerator of our second version of this definition of covariance. So we have n x y bar minus x bar y bar on the top here. So we've derived this formula here. Okay. Now let's just I'll write this down here, and we'll just start again. Then we'll see if we can get from here to here. So we have this as our numerator now. So our covariance xy of xy is equal to n xy bar minus x bar y bar. That's all over n minus 1. Okay, that was our second version. So again, let's just start with the numerator. So we're just going to start with the top part here again. So let's just take n times x y bar minus x bar y bar. Okay, now this is just going to be equal to, let's just have a look at this again. I did this earlier, but let's have a look again. Again, remember, if we take our OR bar, that's just going to be equal to the sum of all our ORs divided by n. Well, here we have xy bar, so that's just going to be that's just going to give us the sum of xy, sum of the xy's, and then we're just going to divide by n. Now, next one, here we have the x bar, so from this here, that's just going to be the sum of our x's, and again that's going to be divided by n. Here we have a y bar, that's just going to be the sum of our y's divided by n. Okay, so let's just have a look at what we can do next. You can see here we've got an n on the outside here of the bracket, so that's n over 1. We've got an n on the bottom here, we've got an n on the bottom here and here, so that's really just an n squared. So if we divide, or take away the brackets here if you like, this n will divide into this n here, so we'll end up with the sum of xy. Over here we'll have this n here dividing into one of these n's here, so we just simply end up with the sum of x, the sum of y divided by n. Okay, now let's just keep going. So next line. Okay, so what we're going to do now is let me see, what will we do? We can, well, we can add these two fractions here. So let's say that's over 1 here, so let's just get our common denominator of n here. So 1 into n is n, multiply the top here by n, so we get n times sigma xy minus n into n is 1, so we just get sigma x sigma y here. That's let me see, n into n, yep, that should work, that's fine. Next line then. Now I'm just going to take this, we have a 1 over n here, this is our 1 over n here, so I'm just going to take that 1 over n outside here, and now I need to write down the sigma xy. Now if this is this term here, so remember I have an n on the bottom here, but I also have an n on the top here, so I need to put that in as well, so that goes in here. Now next one then, I have an n on the bottom here, but I have an n here, so, and I have an n on the bottom here, so really all I need to write down here is sigma x and the sum of y then as well. So this n here will be this n here for this term, if you like. So you'll see if you multiply it out you'll get the same thing anyway. Okay, let's just move on to the next step then. So what we end up with here is the covariance of xy is just going to be equal to, remember this is our numerator, so that's 1 over n times the sum of xy minus the sum of x sum of y. That was our numerator from where we started, and then on the bottom our denominator was just simply n minus 1. So that is we're almost there really. One more step I think should do it. Let me just see here, we can do, oh yeah, well what we can do here is we have a 1 over n here, so what I'm going to do is put this n on the bottom here, so I'll end up with n times the sum of xy minus the sum of x sum of y, so that's going to be on the top, and then on the bottom we'll just put this n times n minus 1 on the bottom here. Okay, so I think that's our third version of our formula. So this is our third version of our covariance formula, and that should be it, I think. Let me just double check that. Is that what we started with up here? Yep, that's this version here. So n times the sum of xy minus the sum of x sum of y over n times n minus 1. So we started with this, our basic definition of covariance, and from that we just manipulated the top to give us this here, and then we took this numerator here and we manipulated that to to end up with this version here. So as I say, different people will use different formula for working this out, and you'll see different versions in different textbooks. But yep, that's it for covariance.